Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive into Apache Regexp. In this tutorial, we'll explore how Apache leverages regular expressions to dynamically route traffic, enforce access control, and create SEO-friendly URLs. If you're familiar with basic regex and want to apply it in real-world web server configurations, you're in the right place. Apache Regexp isn't a separate module, but rather a powerful feature embedded in core Apache directives. It uses Perl-Compatible Regular Expressions to match patterns in URLs, headers, and file paths. This allows administrators to create dynamic, rule-based configurations. Apache Regexp is primarily used in modules like mod rewrite for URL rewriting, mod alias for redirects, mod auths core for access control, and even in custom log for conditional logging. Each module applies regex in slightly different contexts, giving you fine-grained control over server behavior. One of the most common uses of Apache Regexp is the RewriteRule directive. It takes a regex pattern and a substitution string. When a URL matches the pattern, Apache rewrites or redirects it according to the substitution. Flags like R for redirect, L for last rule, and QSA for query string append give you control over behavior. RedirectMatch is another powerful directive that uses regex to match URLs and issue HTTP redirects. It's especially useful when migrating websites or handling legacy URLs. You can specify HTTP status codes like 301 for permanent redirects or 302 for temporary ones. LocationMatch lets you apply access control rules using regex patterns. It matches against URL paths and can restrict access to certain areas of your site. Combined with authentication modules, it becomes a powerful tool for securing dynamic paths. Apache Regexp supports a variety of flags that modify how regex patterns behave. For example, NC makes matches case-insensitive, PT passes the rewritten URL to the next handler, and QSA appends the original query string. Understanding these flags is key to mastering Apache Regexp. Backreferences allow you to capture parts of a matched pattern and reuse them in the substitution. Parentheses in your regex define capture groups, which you can reference as $1, $2, and so on. Apache also supports %n for referencing groups in RewriteCond patterns. RewriteCond allows you to set preconditions for RewriteRule. You can test against headers, environment variables, or file existence. Conditions can be chained with or and logic, and they support both regex and string comparison tests. While powerful, Apache Regexp can introduce performance overhead if not used wisely. Complex patterns or redundant conditions can slow down request processing. Always use the L flag to stop processing when a match is found, and profile your rules using RewriteLog in older Apache versions. Debugging Apache Regexp can be tricky. In Apache 2.2, you can use RewriteLog to trace rule processing. In 2.4 and above, log level alert provides similar insights. Always enable Rewrite Engine and test your regex patterns with tools like Regex 101 to catch errors early. Security is a major concern when using regex. Avoid patterns that can lead to catastrophic backtracking. Always anchor your regex with $, and validate user inputs to prevent regex-based DOS attacks. Limiting backtracking with possessive quantifiers can also improve resilience. Let's look at a real-world example: SEO redirects. When migrating a website, you often need to redirect old URLs to a new structure. Using regex, you can capture dynamic segments like product ID and map them to new paths while issuing 301 redirects to preserve SEO rankings. Another powerful use case is blocking malicious bots. You can use RewriteCond to match user agent headers against known bot signatures and return a 403 forbidden status. Keeping your bot signature list updated ensures continued protection. Apache Regexp also enables dynamic virtual hosts. By using Regex and server alias, you can match subdomains and serve content from corresponding directories. This is especially useful for SaaS platforms where each customer gets a subdomain. While Apache uses mod rewrite for Regex-based routing, Nginx handles it differently with location blocks. The syntax is similar but not identical, and performance can vary depending on your use case. Understanding both helps when migrating or comparing platforms. Even experienced admins fall into common Regex pitfalls. Forgetting to escape literal dots, using dot* too broadly, or omitting anchors can lead to unintended matches. Always test edge cases to avoid breaking your site. Testing is crucial. Tools like Regex101.com let you test patterns live and explain each component. Apache config testers and browser dev tools also help validate your rules. Combine these with log analysis to ensure everything works as expected. You can use Apache Regexp in both htaccess files and main server config. htaccess applies per directory and is slower due to repeated parsing, while main config is server-wide and more performant. The syntax is mostly the same, but behavior may vary. For advanced users, Apache Regexp supports lookaheads, non-capturing groups, possessive quantifiers, and even named capture groups. These features allow for more precise and efficient pattern matching, especially in complex scenarios. Apache Regexp is deeply integrated into the server's core modules and is processed during the request phase. Conditions can be chained, and Apache optimizes performance through internal caching mechanisms, though complex rules can still impact throughput. Let's look at performance metrics. Simple Regex rules typically process in under a millisecond, while complex patterns can take 5 to 20 milliseconds. Caching helps, but using the L flag and avoiding redundant conditions are key optimizations. Regex gives you flexibility, but literal matching is faster. For static paths, use literal matches. For dynamic or pattern-based routing, Regex is the way to go. A hybrid approach often gives the best balance of performance and flexibility. Apache Regexp can also be used in logging. With custom log, you can apply Regex conditions to log only specific requests like filtering out bots or errors. This makes log analysis more efficient and focused. Let's walk through a case study, migrating an e-commerce site. Old product URLs need to be redirected to new paths, categories mapped dynamically, and query parameters preserved. Using Regex with 301 redirects ensures SEO continuity and user experience. In load-balanced environments, Regex can route requests based on URL patterns. You can distribute traffic to different backends based on path, combine with proxy paths for seamless forwarding, and even implement sticky sessions for session affinity. Avoid common anti-patterns like overnesting RewriteCond, ignoring performance implications, or misusing global flags. Also, don't hard-code paths when a dynamic Regex solution is cleaner and more maintainable. In API gateway scenarios, Regex can route requests based on endpoint patterns, validate query parameters, enforce rate limits, and even transform request paths. This makes Apache a powerful front-end for microservices. In modern DevOps pipelines, Regex configs should be tested automatically. Use Apache's built-in tools or third-party validators in your CI/CD pipeline to catch errors before deployment. This prevents live site breakage and ensures reliability. In multi-tenant systems, Regex helps match tenant subdomains and route requests to isolated folders or services. You can even support custom domains per tenant, making your platform scalable and flexible. Regex also integrates with caching layers. You can cache based on URL patterns, bypass cache for dynamic paths, and use mod cache in combination with Regex rules. This improves CDN integration and reduces backend load. Security headers can also be set conditionally using Regex. You can block XSS attempts, enforce content security policies, and customize headers per path. Regex gives you fine-grained control over security posture. In microservices architectures, Regex can route requests to different backend services, transform API paths, support versioning, and handle legacy endpoints. It acts as a powerful API gateway at the edge. Monitoring systems can use Regex to alert on specific log patterns, track error trends, monitor bot traffic, and visualize data in dashboards. Regex makes log-based monitoring both flexible and powerful. Looking ahead, Apache Regexp is evolving. Expect better integration with AI-based config tools, enhanced caching for performance, improved debugging interfaces, and support for modern Regex syntax standards. To wrap up, mastering Apache Regexp means understanding core directives, testing and profiling regularly, optimizing for performance, and securing your rules against abuse. With these practices, you'll be ready to handle any routing or access challenge. Thanks for watching this deep dive into Apache Regexp. If this tutorial helped you level up your Apache skills, smash that like button, subscribe for more DevOps content, and drop your favorite Regex tip in the comments below. See you in the next one. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.